All right, welcome back, Algebra 1. First recommendation for you is to go back and start watching some of these videos again. Any section that you guys are not feeling confident with, that's step one. All right, go back, rewatch those videos, make sure that you understand each step in every example problem that I did on the board, okay? Today, purpose here is we have a review video where we are covering one problem from every section that we covered in the chapter, okay? So I have the problems numbered as this is from section 1, this is from section 2, 3, 4, and section 5, okay? So track with me, follow along, make sure that you guys are doing the problems with me, or you can track and follow with me. Go back and rewrite all this work. These are going to be helpful problems to have on that one page of notes that you guys will always get to utilize come test time. So make sure that you're putting in the time, because then you will be fine. All right, I remember that was what my AP Calc teacher always told me. Put in the time, you'll be fine. So that might mean going back again, watch those videos, rewatch this video, ask me questions, and just keep reviewing. All right, don't give up, keep trying and pushing. All right. So let's jump right into it. Okay, first problem here from section 1 talks about inverse variation. All right, and I wrote up the equation just as a reminder. This is the equation right here for inverse variation. Y equals k over x. All right, k stands for the constant of variation. All right, now they will first give you x and y and expect you to solve for k. Once you have k, you will then move on to the second part of the problem and find y when you have a brand new x. All right, so step 1, use x and y to solve for k. Let's jump in and get that going. So we're going to set it up as we have 21 equaling the unknown k over 3, which is x. And we can rearrange this if we want and actually make it say k equals 21 times 3, so k equals 63. All right, so that's step 1, get k. Then rewrite the equation. So we're now looking at y equals 63 over x. And they're going to say find y when x is 5. So plug that 5 right in there for the x. So now you're looking at y equals 63 over 5. And you're going to go ahead and want to reduce that down, do the division, and you're going to get y equals 12.6, I believe. I want to make sure my calculation's right. That's good. It is 12.6. Okay, so track with each step. Inverse variation, here's the equation. Step 1, here's x, here's y, solve for k. That's this guy right here, tracking with every single step. Once you have k, rewrite the equation, and then look at the second half of the question. Here's a brand new x, solving for a brand new y. That's this, and then simplify it. That's our final answer for y. Okay, so here's the equation, and here's the brand new y. All right, let's move into section 2. We are simplifying. I see a trinomial, another trinomial. We're looking at two quadratics here. Probably can factor these guys. All right, so let's go ahead and factor the numerator, and we will also factor our denominator. Okay, with the last sign here being minus, that means my signs in the parentheses are going to be opposite, plus minus. Now, I do have a coefficient a value. It is 3. So let's try putting the 3x here and just a regular x right there. And then we still need to factor that 2. which is a prime number. So I only have 2 and 1. Do I put the 2 here? Do I put the 2 here? We need to check it. Let's try putting the 2 here and then putting the 1 here. All right? Now, how do we check if this is the correct factor? We're going to do the double chin guy. I know this is kind of like, we'll say this is the inverse of double chin guy just because I'm doing it upside down. All right? So 2 times x gives us 2x. And this one right here, 3x, and a negative 1 is a negative 3x. What is 2 minus 3? It is negative 1. So this one works. This is the proper factoring of this trinomial. Now let's do it for this one right here. All right? So I see a plus sign. That tells me that my signs in the parentheses are going to be the same. Now what are they? They are this sign. They're both negative. All right? I have a 2. That's a prime number. Let's go ahead and put the 2x here and the x here. And 1. That's another prime number. That's great. So I just put the 1 here and the 1 here. And we know that this has to work. All right? Why does it have to work? Here's why. The signs in the parentheses are the same. The 2 is a prime number. There's only one option of factoring that. The 1, it's a prime number. There's only one option of factoring that. So this one has to work the way that it is. Take a look at the top and the bottom. I see x minus 1s on both top and bottom, so they can be crossed out. Remember, it's an all or nothing situation. You can't just cross out the x or just cross out the 1. It has to be the whole expression. X minus 1 gone, leaving me with 3x plus 2 over 2x minus 1 as my final answer. All right, so that's for section 2. Let's take a look at section 3. We're looking at division. And remember, what do we do with division and fractions? We use KFC, keep, flip, change. All right, so KFC, keep, flip, change. That's always what you do with a fraction. You never really divide. You always switch it up and make it multiplication. So let's rewrite this. X squared minus 9 over 2x plus 1. Keep the first. Flip the second and change it to multiplication. So we're going to flip this and we change division to multiplication. So we now have a 4x squared minus 1 over an x plus 3. Okay. Now, when you look at the whole problem, this 2x plus 1, nothing can happen here. X plus 3, nothing can happen here. But the x squared minus 9, I can factor that. That's a perfect square binomial. 4x squared minus 1, that's another perfect square binomial. And the final piece, some of you guys may say, oh, don't you have to have common denominators? Remember, no. When you multiply or divide, you do not need a common denominator. That will come in the next problem. Actually, sorry, right here, this problem and this problem. But when you multiply or divide, no, you do not. All right, so we can immediately say this is good, but we got to factor these guys up here. So let's rewrite x squared minus 9, perfect square binomial. It's going to be x plus minus 3 and 3 over the 2x plus 1 times, and then the x plus 3, there's that. 4x squared minus 1, remember that is a perfect square binomial too. So this becomes 2x plus minus. How do I know it's plus minus? Because that sign's a minus. Always has to be opposites to create a negative. And then 1 and 1. You should see some stuff here. What do you see? I see an x plus 3 and another x plus 3 that can be crossed out. Anything from the top, matching something from the bottom, totally crossed out. The whole expression, though, has to be crossed out. I see a 2x plus 1, another 2x plus 1, fully crossed out. What is left? X minus, sorry, I'm going to get some space over here. X minus 3 and 2x minus 1. All right, there you go. That is what is left over from that whole problem. So just show them next to each other and you're good. You don't have to use the distributive property. You can leave it as two sets of parentheses. All right, section 4, I see a plus sign. And when you're adding or subtracting fractions, yes, now you have to have common denominators. Can I make the 6 become a 9? No. Can I make the 9 become a 6? No. So we got to think through, what would our common denominator for this problem be? We are looking at that common denominator being basically 6 times 9. That's an option that you can take. And can x become x to the third power? Yes, it can. All right? So let's go through and start our multiplying here. This x needs to have x to the third, and it also needs to have a 9. So I'm going to multiply this side by a 9x to the squared power. All right, why is it squared? Because I already have 1, and if I multiply it with 2 more, that's going to give me 3. So now we're looking at down here, multiplied by a 9x squared. This one already has the x to the third power, but what are we missing? We need to multiply it by a 6. All right, so let's multiply it by the 6 here, and then we're going to proceed by getting our multiplication. You know what? I just noticed, way simpler method here. This would be one of those moments in class. Hopefully someone would have corrected me. I'm just correcting myself right here. 6 and 9, can't they equal something a lot smaller? This is where the math teacher would have made it way more difficult. They could equal 18. Probably had some of you figure that out as you're watching this video. So let's switch that up. How can 9 become 18? Just multiply it by 2. Oof. Let's make it easy on ourselves here. How can 6 become 18? Multiply it by 3. All right, so we're looking at a 3x squared. That makes our life a lot easier. Now, the x to the third, I still needed that. So this x only had 1, but if I multiply it by 2 more, that's how I get the 3. So now my common denominator is looking like 18x to the third for both of these guys, and 2 times 1 is 2. 5 times 3 is 15, and then the x squared gets tagged onto it, and now you just need to show it all together. So 15x squared plus 2 all over 18x to the power of 3. And that looks much better. My apologies for the start of that. 6 times 9, that's going to be way too big. 18, a lot better. All right. Section 5, last section. Remember, we skipped section 6, so we're ending it at section 5. Now, this looks like another one where we're going to need common denominators, and we now have 3 fractions. If you look back at the section 5 video, when you have 3 fractions and you are looking for that common denominator, you may just need to show the 2 different denominators